I had some students talking this morning about access codes. We're getting that straightened out eventually. Again, let me go ahead and say it. If you having trouble with your access code and you get the invalid access code error, there's two options. One is to return the code and the book if you haven't used it or opened it, or go back and talk to them and see if they will make it good. What you would like to do is to just get the access code online, okay? They have fixed the problem with the buy now feature. It is available, and so is the 21-day or 14-day, whichever one. It says 21-day, but some people told me it's 14. I don't know. Just don't let it expire. So that's the first option, for you to return your unused materials and just say you want to buy it online, okay? Now, whether it's opened or whether it's not opened, that you take up with student records, okay? The second option is to email me and send me a picture of the error code on the screen and send me a picture of your code to where they can zoom in and read the code, because I send it to my department head and she sends it to Pearson, okay? So that's your two options. I know somebody emailed me this morning. Who emailed me this morning? Somebody did. Okay, well, let me pull it up and see, because I can't talk. I got one this morning. I just want to make sure.
I emailed you last night.
That might have been it.
Yes.
What, was it on there?
It was 8.
Okay. Is that it?
The one below it.
One below it. Okay, I need to send you that. Let me send it to you after class, okay? Did you send me a picture?
I did not. I kind of explained it.
Okay, all right. We'll talk about it after class.
Okay.
All right. Make sure you get that in, okay? Oh, gosh. I hate this email system. Mr. Flatt, you didn't get that email, did you?
No, sir.
I'm sorry. I just get so irritated. It goes to you, and then you end up sending an email to yourself. That is so frustrating. You have to be on the person's email, or sorry. I'm trying to get all these fixed, and it's kind of hard when. There we go. Just do it. Okay. So, those of you, does anybody have any questions on what I just said? The two options. Go up to student records with your materials, tell them what the deal is. If they don't, return it. If they don't, give you your money back, and then you can go online and get the, if that don't happen, then you email me, send me a picture of the code that you scratched off the cover, and send me a picture of the error code that's on the screen. Those two things, I'll send it to my department head. She sends it to Pearson. They document it. Okay? Any questions? Anybody got any questions on anything pertaining to My Labs Plus or anything? No. Okay. All right. Well, what we're going to do is we're going to actually start today. So that means that you need to start your homework, whatever we cover today. And what I'm going to cover today is basically review. And I'm going to cover a little bit of everything that you're supposed to be reviewed on. And like I said, some of y'all probably have had Math 102 or 101 last semester.
No.
How long has it been since you had 101 or 102? Or Algebra 1 or Algebra 2? Or
Algebra 1 or Algebra 2?
Yeah.
3 years.
Yeah, it's been about 3 or 4 years. How about the rest of the class? You just give me a time.
8th grade.
8th grade? High school?
8th grade.
8th grade?
I don't remember.
You don't remember?
I think
8th grade?
8th grade.
8th grade. How about you, Pendleton? Go around the room. How long has it been since you had Algebra 1, Algebra 2, 101 or 102?
A month.
A month? So you just come out, okay. I think we might have had this discussion, and if we did, great. How about the rest of y'all?
Like first year of high school?
Okay, now I'm not picking on you, but I have no earthly idea how old you are. How old are you?
Me? I'm 18.
Who's speaking? Okay. So you had, okay, and what about the rest of y'all?
2 years.
2 years? Spit out another. How long? Miss Whiten, how long? Pendleton's not going to talk to me, so how long?
Algebra 1, that was 8th grade. And I'm
So
a
it's been
senior
several
now,
years ago.
so yeah, it's been a while.
So you need this review because some of y'all pretty much suck at it, or some of you basically haven't remembered it or haven't, done it in a long time. So it's kind of like a rusty chain on a bicycle. You need to spray some WD-40 on it. So what do you need to learn? Well, there's several things you need to learn. We need to go over polynomials. We need to go over factoring. We need to go over exponential laws. And we need to go over a little bit of graphing. So what I'm going to do is I'm going to cover most of this, and then the questions that you send me from the review are going to fill in the gaps. All right? No questions sent to me? What does that mean?
Got it.
You got it. So I don't have to go over anymore. You send me questions, we fill in the gaps. So let's go over the first thing, polynomials. Polynomials are basically several term algebraic sentences. All right? So a monomial is 2x squared. A binomial is 2x squared plus x. A trinomial is 2x squared plus 3x minus 2. Those are polynomials. Now you can have a fourth term polynomial, a fifth term polynomial, sixth term, and so on. But most of the time, 90% of the time in algebra, we deal with those three. A fourth term polynomial I'll throw up here. Fourth term polynomial is 3x to the third plus 4x squared plus 3x minus 6. Now, after you have been introduced to polynomials, you need to learn how to add, subtract, multiply, and divide them. And that's where everything gets kind of crazy. All right, so let's go ahead and review adding. Adding like terms. Now, what's the same thing as adding like terms? Subtracting like terms. Okay? It's called combining like terms. Write that down for adding and subtracting. It's called combining like terms. If you have two binomials, 2x squared plus 4x times plus, I'm used to times them all the time, plus 3x squared minus 2x. The first thing you do is get rid of the parentheses. How you get rid of the parentheses? Well, in front of every set of parentheses, there's a number. And if there's nothing there, it's assumed to be a what?
1.
A 1. So you distribute that 1, and since 1 is a multiplicative identity, it doesn't change anything. But you got to remember to distribute, because you have to distribute to get rid of the parentheses. It's a technicality with 1, but the other numbers, it's not a technicality, and if you don't do it, you're going to get the problem wrong. So, 2x squared plus 4x plus 3x squared minus 2x. Now here we have a polynomial, and we have terms inside that can be what? Combined, because they are alike. Think of it like this. When you go to the grocery store, you get 3 boxes of cereal plus 2 boxes of cereal. You got 5 boxes of cereal. They may be cornflakes and Raisin Bran, but they're boxes of cereal. Boxes of cereal is a label. Okay? X squared is a label. X is a label. X squared is like boxes of cereal. X is like can of beans. You can't add a box of cereal and a can of beans and get a box of cereal. All right? So think of it as apples and oranges. So here we have 2 boxes of cereal plus 3 boxes of cereal equals 5 boxes of cereal. 4 cans of beans minus 2 cans of beans is equal to 2 cans of beans. And that's the way you combine like terms, whether you subtract or add. Now, which one you have to be more careful with?
Subtracting.
Subtracting. Why? Because if you put a subtraction symbol in front of one of these parentheses, it changes the whole game. 2x squared minus 6 minus 3x squared plus 7. Now, instead of having a positive 1 in front of, you got a positive 1 here, but what do you have here? You have a negative 1. Now, distribute that 1 and that negative 1 and do the math. Do that right quick. Now, there's 2 types of people in the class. There's one that's saying, oh, God, I don't want to do this. Well, then be quiet and shut up. The second one is like, oh, yeah, I remember this. That's who I'm teaching to. I'm not teaching to the person that built the space shuttle. Okay? I'm dealing with the person that's trying to learn how to do algebra. So if you built the space shuttle, stay at home and find a cure for cancer. Distribute the 1 and distribute the negative 1. And that's going to come out with 2x squared minus 6 minus what? 3x squared what?
Minus 7.
What is the most popular mistake students make with this negative 1 right here? Anybody want to
Just
take a guess?
multiplying it. Just multiplying it times the first term.
Thank you. Wow, that's Pendleton. They interacted. All right, so negative 1 is right here. That is the most common mistake. So you need to highlight that negative 7, because if you're going to screw it up, that's where it's going to be. That's why, Hubert, if you walk into my classroom 5 years from now and you're helping your kid with algebra and you come to me and say, Hubert, how do you do this problem? I got to show my son. Would I put the arrows? Yes. I put the arrows if I'm doing a test. I have several degrees. How many degrees do y'all have? Yeah, I thought so.
Working on my third.
Okay, so, on astrophysics or what? Okay, so if I put these arrows and I do a problem and I've got several degrees, what does that mean? That means you need to do it. Now, if you do 10 out of 10 problems right and you get them right, then you don't need to draw the arrows. If you do 10 problems and you get them all wrong, then something's broke. And if something's broke, you need to what? Fix it.
Fix it.
Put the arrows. Okay? And you won't forget to multiply that negative 1 times that negative 7. And now what's 2x squared? What's 2 boxes of cereal minus 3 boxes of cereal? Negative 1 box of cereal. And what's negative 6 can of beans? You owe 6 cans of beans and you owe 7 cans of beans. How much do you owe? You owe 13. Now, no, you do not have to put the negative 1, but you have to put the negative. So that would be negative x squared minus 13. Now, that's a review of combining like terms. Multiplying. This is called what? The distributive law. Now, the distributive law is the granddaddy. The distributive law you can use all the time. What do you mean? Well, if I give you 2x plus 3 times x squared plus 3x minus 2, what would you use?
The distributive property.
Law. Say again? What?
The distributive property.
You would use the distributive property. Thank you for the interaction. You know people are going to fuss at you because you're interacting. You're supposed to sit there like a tit on a bull. You're supposed to sit there and not say anything. Okay? Somebody's going to say, I said a bad word, aren't they?
Algebra.
Yeah, algebra. I'll hear about Hubert, I'm concerned. 2x times x squared, that's x to the first power, is 2x to the third power. 2x times 3x is 6x to the what? Second power. You got to add the exponents. Don't forget to add the exponents. Oops. Two times 2, that's a negative 4, x to the first power. So we're done with that part. Plus 3x to the second. Plus 9x to the first. Plus or minus 6 what? X to the 0. Just in case y'all didn't know, 0 plus 0 equals 0. Some of y'all have no earthly idea what I'm talking about. It's called product rule. You add the exponents. Anyway, 2x plus, where's it? We have another cube anywhere? Nope, so you just bring it down. Combine like terms. Need another box of cereal. Here's one. 9x what? Squared. Now we need cans of beans. Negative 4, you owe 4 cans of beans, but you got 9. So you have what? 5 cans of beans. And then this guy, he just comes down because he really don't matter because he's by himself. So that's your final answer. And yes, you don't need the x to the 0. I do the x to the 0 and put the 1s in front of, just so people can remember. Okay? And that's how you multiply distributive law. Now, distributive law has no what? You use it all the time, so you have no restrictions. Well, Hubert didn't, I remember some about FOIL. Well, we're fixing to talk about that, but you need to know that when you can't use the FOIL method, you fall back on what? The distributive law. A lot of people get the two mixed up. They say, well, I don't know when to use what. Well, you can use distributive law anytime you want to. The FOIL method, pronounce it however you like, is when you have two what? Multiplying two binomials, Hubert. That's right, class. When you're multiplying two binomials. Now, I want you to do the following problem from memory, and if you can't do it, just consider that a disappointment. And you are a disappointment to the class. X minus 4. And I want you to do the FOIL method the way you learned it. And if you didn't learn it, just sit there and be a failure. The first, the F stands for first. X times X is X squared, because this is to the first power and that's to the first power. Add the exponents. The O, depending on where you're from, stands for outer. Or if you're not from around here, it's outside. Okay? So outer, x times -4. The I stands for inner, or inside, 2x. And then last is negative what? Now, when you use the distributive law or the FOIL method, what's the next step usually? From now on, we're going to call it CLT. And what usually follows the distributive law or the FOIL method? Combining like terms. So you need to write that down, because every time you use distributive law or FOIL, 95% of the time you're going to combine like terms right after. And cans of beans. X squared minus 2x minus 8. And all this should be like, oh yeah, I remember doing that. Did you access code word?
Oh,
You tried it yet?
Yes,
How
sir.
about you? Question on this. Now, when you divide polynomials, there's two types of division. Well, really 3 types of division with polynomials. There's dividing by terms. Then there is factoring. Then there is long division. Now, dividing by terms, what's that? Well, that's the easiest one. X to the third minus x squared plus x divided by x. Now, what's the answer to that? Well, subtract. Use the quotient rule. When you divide, you subtract what? Exponents, Hubert. That's right, class. So what's 3 minus 1?
2.
What's 2 minus 1? What's 1 minus 1? 0. So that's x squared minus x plus 1. So that's when you divide by terms. Usually it's a single term on the bottom, and you divide by that term. You subtract the exponents. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Now what about the signs in front? They don't matter. They just come down. Factoring. You're going to use the reverse FOIL. Okay? Now, if you suck at the FOIL method, then what does that mean about you and the reverse FOIL method? You're going to suck at it. So if you have never learned the FOIL method, then you're going to really suck at the reverse FOIL method, because you're undoing it. All right? So, now, right quick, if I told you to factor 54, most of you, 99% of you, would say what? Not 6 times 9. That's what everybody says. Only 1% of you will go, that would be 2 times 27, I believe. Okay, nobody thinks like that, all right? Most of you think 6 times 9 because you're multiplication tables. So I just factored 6 times 9. So I broke this big number into 2 what? 2 factors. That's what you're doing with the reverse FOIL method. You're breaking a x squared plus 4x plus 4. You're breaking a 54, this big thing, up into 2 binomials. First thing you do is draw 2 sets of parentheses. Break up the first term starting with x. Break up the last term starting with 1. 1 times 4, 2 times 2. 2 times 2, and 1 times 4 will always give you a 4. 1 plus 4 will give you a 5. 1 minus 4 will give you a 3. 2 plus 2 will give you a 4. 2 minus 2 will give you a 0. The middle term is what?
4.
4. So we need a 4, and the only one that will give us a 4 is what?
2, 2.
2 and 2. So you put a 2 here and a 2 here. This sign right here tells you that the biggest number of the outside and the inside, remember your outside and inside, has to be equal to a positive. So that means the largest number has to be positive. Where since they're both the same, 2 and 2, you can just pick one. What does this mean? Has to be like, because it's multiplication to get 2 times 2 is equal to 4, so it has to be like signs. So this is plus, so your answer is x plus 2, quantity squared. Now, we're going to get to the shortcuts in just a minute. So those of you that say, well, I remember doing it a different way, just be quiet. Okay? We'll get to that in just a minute. That's how you do the reverse FOIL. Now, if I put a 2 or a 3 out here, it's going to change it, and you're going to have to work a little bit harder, and we'll be doing some of those on the homework when you send me the homework questions, because you will. Okay? Unless all of you build the space shuttle. Okay? So let's just go to the next page and go over long division, which we're going to go over again probably, but I'm just giving you a little small example. Long division. X minus 1 into x squared plus 3x minus 3. Now, some of you may have seen this before, some of you may have not. We're probably going to go over it again later on, but I just wanted to show it to you because you're doing division, and that's one of the things that you're going to, we're going to go over probably in the second chapter or third chapter when we're actually trying to find whether vertical or horizontal asymptotes, which is the dashed lines that you never touch. Okay, so this is x to the first power. Always remember, this is the guy that you're worried about. This is the kite on the tail. The minus 1, you really don't need to worry about it. You need to worry about the x to the first power. How many times will x to the first power go into x to the second power? Be careful, because y'all going to say 2 or 3 things and you're going to be wrong. Remember, product rule. How many times will x to the first power go into x squared? Nope. 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 You're all failures, okay? So, x to the first will go into x to the second, x to the first times, okay? Because when you say 1 times x is 1x. That's not what you're looking for. Well, 2, I said 2. 2 times x is 2x. That's not what you're looking for. You got to think in terms of the exponent. So, x to the first goes into x to the second, x to the first times. X to the first times x to the first is x what? X squared, Hubert. That's right, class. X to the first times negative 1x is negative what? Negative 1x. What do you always do when you do that line right there? What do we always do? Let's go back and check. Let's go back to 2nd grade or 3rd grade. 2 will go into 7. 2 goes into 7 3 times. 3 times 2 is 6. What do we always do?
Flip
We always
line.
subtract. So that's what we're going to do here. Now, if I subtract this whole quantity, what am I going to do with that negative? I'm going to what? I'm going to distribute it. So I can draw it like this, or I can erase those parentheses and I can just put a negative here and make this a what? Positive. And what will happen to the left side always? It will always cancel. And that leaves you with 3x plus 1x is what?
4x.
4x, and the negative 3 comes down to help out. How many times will x go into 4x? Now it's time for that number. Well, how many times will x go into 4x?
4.
4 times. So we put a positive 4 here. 4 times x is 4x. 4 times negative 1 is what? What do we always do? Subtract. So that makes that a 4x and makes that a negative 4x makes that a 4. And what happens to the left-hand side? It always goes out. And what is negative 3 plus 4? 1 remainder. Okay? So that's a little preview or a review, depending on who you had for Algebra 2, or, you know, and we'll go over that again, but I just wanted to show it to you, not for instruction, but for a review, just so you can think, okay, that's division. Comprende?
Mm-hmm.
Comprende. All right. So what's left after division? $0.25 word for what? Substitution. And we're going to go over this again with functions. I'm not worried about it right now. We're going to go over it again. So this is just a little bit of preview, review of coming attractions. So if I give you y is equal to 2x plus 3, and I give you x plus y is equal to 7, what are you going to tell me to do next? Yep, give up. That is the best thing to do, or quit. Okay? Give up or quit. When the tough gets going, what do? You blame Russia, blame Russia, and blame Russia. That's what you do. So, what do? Somebody tell me, seriously, what do we do?
Plug in y.
Plug in y. So this is equal to y. So I'm going to take my handy dandy highlighter, and I'm going to highlight that guy right there, because that is equal to one variable. And I'm going to take that, and I'm going to plug it into wherever there's a y. Right there. So, I got x plus, I'm going to put a parenthesis here, 2x plus 3 is equal to 7. Now I'm going to distribute that 1, that positive 1 right here, I'm going to distribute it. And that gives me x plus 2x, and I'm going to put a little 1 here so we remember that there's a 1 there, because some of y'all think there's a 0 there. And if there was a 0 there, it wouldn't even be there, because 0 times x is 0. So your philosophy of a 0 being there is wrong. It's a 1. Plus 3 is equal to 7. And what's 1? And what did we do here? We used the distributive law. What usually comes after distributive law? CLT. And what's 1 box of cereal plus 2 boxes of cereal? 3 boxes of cereal. And you can finish by solving for x. Okay, I'm not going to go through that. Just put 3 dots. You don't have to do it. You can if you want to. 3 dots. And I'm just showing you how to substitute. Now we're going to go over that in composition of functions back in chapter 3. I think all of this, a lot of this is going to come up in chapter 3, but we're working with it. We'll work with it as we go. Question? Okay. Now, shortcuts. And this is what I call the shortcuts. Not the books don't call it shortcuts. Your teacher may not have called it shortcuts, but I do. I call it shortcuts 1 through 5. Number 1. A plus B, quantity squared, is equal to A squared plus 2AB plus B squared. 2. A minus B, quantity squared, is equal to A squared minus 2AB plus B squared. And I've got an error here. I need to make them lowercase, because you don't make uppercase and lowercase because of your sciences. You got to stick with, there we go. 3. A squared minus B squared is equal to A plus B times A minus B. 4. A cubed, A plus B, no, A cubed plus B cubed, I get them sometimes mixed up. Sorry, just erasing. A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared, and 5 A cubed minus B cubed is equal to A minus B times A squared plus AB plus B squared. Now all of you should be saying, oh yeah, I remember those. I didn't use them because I didn't want to learn them. Okay? A lot of people in Algebra 2 or 102, they don't commit them to memory because they feel like, oh, I can just use the reverse FOIL method. Yeah, and they can't figure out why everybody's finished with the test and they're still on number 10. Because these save a lot of time. But you got to know how to use them. You got to remember your perfect cubes. I would say make a index card, x, and then x squared, and x to the third, x 1. 1 squared is 1, 1 cubed is 1. 2 squared is 4, 2 cubed is 8. 3 squared is 9, 3 cubed is 27. 4 squared is 16, 4 to the third is 64, and so on. 5 squared is 25, 5 to the third is 125, and so on. I would say you need to learn it down to 15. 15 squared is 625. Y'all check me. And then I don't know what 6 stands. I'm not Rain Man. 15 to the third is some BA number. But I would highly suggest, if you don't know your cubes and your squares, you need to write an index card and you need to fill them out. Because you're not going to be able to do these problems unless you know your cubes and squares. Okay? So let's do one. Let me take my handy dandy eraser and erase this. And you know what? You can go to Google and put perfect squares and perfect cubes and print it out and put it on an index card. But that would require you to type in perfect squares, perfect cubes, hit the print button, and tape it to an index card. It's a lot of work. I do realize that that's a lot of work for some of y'all, but you might want to invest in that 5 or 6 minutes of work to do that. It's easier to just say it's too hard, right? Too difficult. Group.
Move that up.
Let's move it up a little bit more. Y'all are impressed, aren't you? All right, so here we go. X squared minus 4. That's what you're given. So the first thing you do when you see x squared minus 4 is you match it up to whichever one matches the best. And which one is that? Well, let's go ahead and use what Sherlock Holmes used. What did Sherlock Holmes use the most? Law of what? Deduction, Hubert. That's right, class. Deduction. That's getting rid of the ones that you know is what? Not. Which two do you know that it's not? Why? You are just exceptional. Why is 4 and 5 not the answer? They're perfect cubes. You're in perfect squares. How do you know that? Well, 1, you know 4 is usually a perfect square, and the x squared is telling you to find the perfect square. Okay, so that's it. So you knock it down from 4 and 5 to 1, 2, and 3. Which one, well, let's see, this one don't have parentheses. Which one initially on the left-hand side does not have parentheses? Or does have parentheses? 1 and 2 has parentheses. So that kind of narrows it down to what?
3.
Shortcut number 3. So you put shortcut number 3 right up under it. A squared minus B squared. equals A plus B times A minus B. Now, I don't want A squared and B squared. I want what? A and B. So I'm going to take the square root of this guy and the square root of this guy. What's the square root of X squared? What's the square root of 4? Plug and chug. X plus 2, X minus 2. So now, when you're given X squared minus 9, you know the answer is X plus 3 times what? X minus 3. If I give you X squared minus 25, X plus 5, X minus 5. Shortcut, number 3. Knocking some of the cobwebs loose, Miss Whiten?
Mm-hmm.
About Pendleton, for the one person that's going to say something.
Yes, sir.
Thank you. I can rely on you. You'll get the A out of the class. Everybody else will fail. All right, so let's try another one. Let's try. Still no response. I just sit there like, did you say something? I didn't. And people wonder why classes are so boring. Not the teacher usually. It's usually the class that sets that. X plus 4 quantity squared. All right, now I want you to deduce which ones it's not. It's not 4 and 5. Boy, I tell you, I can't get nothing past y'all. Why is it not 4 and 5? Because it's a square. It's not a cube. Okay, well, which one does not have parentheses? This one has parentheses. So which one of 1, 2, and 3 does not have parentheses on the left-hand side?
3.
So it's not number 3. So that kind of narrows it down to number 1 and 2. And which one does not have a negative? Or has a negative? Number 2. So that means that we are going to use number what?
1.
Number 1. And I'm going to put number, I know, isn't it something? And I did all that without even writing anything on the paper. It's called mental work. So, A plus B, you'd be surprised how many teachers teach this and you don't know whether to eat or go blind. A squared plus 2AB plus B squared. All right, now I want you to tell me what A is. Well, all you got to do is draw an arrow. And B is what? So A is equal to X. B is equal to 4. Now I want you to plug and chug. But I want you to be careful because you're going to make one of the most common mistakes that you can make. And if you make it, just consider yourself a loser. McDonald's is hiring. You can make your career out of, they get these wages up, you can make a career out of being a cashier.
That's crazy.
Tell that, shut up, Hubert. Shut up, Hubert. Right side. Yes, son, if you work hard, wages go up, you can make your career out of working at McDonald's. Take that part-time job for high school students and college students. Make a career out of it. The government can control you even better. I think I did pretty good there. I think I did pretty good, don't you? I didn't go too far. Okay, so I'm going to put parentheses. Why, Hubert? Because I don't want to screw this up. Why would you screw this up? Somebody want to take a guess why you would screw it up? Because there's two things in the world of mathematics that students hate. What are they? You want to take a guess? Besides word problems. There's two things that students hate in mathematics. What are they? Fractions and negatives. And if you plug in a negative or a fraction the wrong way, or if you don't make sure you make a middle note to square it, you're going to screw it up. So that's why I put the parentheses. And yes, if you walked into my class, if you walked into my office today and said, Hubert, I need you to do a problem, would I put the parentheses? Yep. But I realize some of y'all don't need that. Yeah. And of course, on a scale of 1 to 10, this is a 1. I'm talking about when you get to a 10. You need those parentheses. X squared plus 8x plus 8, right?
No.
What's the most common mistake students make on this problem? They change that 4 squared. 4 squared is 8. That's what they do. They say it's 8. X squared plus 8x plus 8. That's what they get wrong. All right, now you ready for this one? I'm gonna really test y'all to see if you can use that noggin. Mr. Bays, you with me? Good? You're not confused, are you? Okay, good. All right, I'm gonna even give y'all a small. I'm gonna give you just a little number, okay? Now, do it. Find out which 4 it is not. I'll even give you a hint. Which 3 is it not?
1, 2, 3.
Let's just go on calculus.
I need a trophy.
Yes, you know what you need? You need a trophy. But then I'd have to give everybody else.
Yeah.
Because I can't put you above them. Yeah, that's called motivation. Can't give Mr. Bays a promotion when he's at work because that would hurt everybody's feelings and they'd have to go get a puppy and go to a crime closet. Oh, shut up. Don't say that. You want to keep everybody mediocre and average. Pendleton is like, what the hell is he talking about? That's all right, Pendleton. Just do the problem. Miss Whiten, she's lost. She's just sitting over there going, I don't know what to do. I'm kidding. It's a joke. I have to pick on you, Miss White, because Pendleton won't talk to me. Only one person will talk to me. And
Yeah,
I'm scared,
I'm the only one here.
I'm scared to push that person too much. She may quit on me. All right. So we numbered out what we deduced that 1, 2, and 3 does not work. So that leaves 4 and 5. Which one is it? Number 5. A cubed minus B cubed equals A plus B. Sorry. A minus B. Sorry. Jump the rails there. A minus B times A squared plus AB plus B squared. Oh gosh, we got to find what A is. A is equal to X. B is equal to, I don't know, what's cube root of 8? I have no clue.
2.
2. That's why you got to know your cube roots. Because I could easily put a 125 there or a 64. And the cube root of 64 is not 8. That's the mistake people make. Cube root of 64 is 8. And that's wrong. So you got to know your perfect cubes. You got to know your perfect cubes, and you got to know your perfect roots. If you don't, then you'll pretty much suck at this. So that's going to be x minus 2, x squared plus 2x plus what?
4.
Good job. Thank you for the interaction. Now, hopefully that brings some of your bust up some of those cobwebs. Hopefully you're saying, oh yeah, I remember doing this.
Yeah.
Good. That's a good thing. Make sure you write these down. Miss Whiten, what's your major going to be in the future?
I don't know.
You don't know?
No, I just know that I'm going to be an X-ray tech. So, I mean, if I had to pick a major, I guess it'd be anatomy. So.
Okay, so you're going to have to take calculus at least. A lot of people have to take calculus, at least the first variable calculus. If you take calculus, the shortcuts are going to follow you all the way to calc differential equations. For those of you that don't know what differential equations is, it's calculus, calc 2, calc 3, and differential equations. And the shortcuts will follow you all the way to differential equations. So if you want to go ahead and choose to suck at those 4 classes, then go ahead and not study these 5 shortcuts, and you'll pretty much seal the deal on sucking at those 4 classes. Okay? All right. Y'all settle down, Pendleton. Y'all getting too loud. Now, something you're going to go over, and I'm going to go ahead and show you now, but we're going to spend all of Unit 1 and Unit 2 going over this. But I want to show it to you now so some of y'all kind of break the mold on the memory there, and that is completing the, anybody want to fill it out?
Where?
Good job. Completing the square. Yep. I wish I could hand y'all trophies out, but I can't do that. Completing the square. Some of y'all probably have never heard it. Well, that's bad. That means you might as well quit. We're going to spend all of Unit 1 and all of Unit 2, wherever we factor from now on, we're going to factor using completing the square. Why? Because the first review chapter in Calculus 1 is made up of reviewing over the important topics of algebra. And in this notebook that you're keeping right now, make sure you keep it on a bookshelf because you're going to need it the first week of calculus. All right? This notebook that you're doing right now, you're going to need because there's going to be a lot of people that's going to be taking calculus right after trig, and they have not had algebra in 4 or 5 years, and they're going to really struggle that first test. So make sure you keep this notebook. If you're going to take calculus, make sure you keep this notebook for that first week. And this is one of the big topics on that first test, completing the square, along with factoring. They don't use shortcuts that much as a part of the test. They just use factoring in general. They'll throw up a trinomial and say factoring. All right? But this, they're going to hammer this in the first week. I know I do with my calculus class, so you better get used to it. This is the non-restrictive factor method. Okay? Non-restrictive factor method. This is like long division for division and like the distributive law with multiplication. Any trinomial you can factor with completing the square. Now, Hubert, you didn't go over what we were told we had to learn in high school. And that was that stupid quadratic formula. The reason you don't use the quadratic formula is only used with decimals. Okay? Now, a lot of you business majors that's going to go into Math 130 and Math 230, you're going to see a lot of decimals. You're going to see a lot of not of completing the square, because if you try to use complete the square with decimals, you're going to pull your hair out. Okay? But that's what the quadratic formula is used for. And that's what makes me so it gets under my skin when I hear that high school teachers spend a whole unit on quadratic formula. They should be spending the whole unit on completing the square, because most of you trinomials are not in decimal form. Okay, they're in whole number form. Whole numbers, complete the square. Decimals, quadratic formula. Because what do you depend on with the quadratic formula? Your calculator. Okay? All right, what is this going to find? This is going to find your x-intercepts and your vertex. The quadratic formula only gives you your x-intercepts, and you have to plug it into another formula to find your vertex. So that's why a lot of calculus teachers hammer that first review. They hammer the completing the square because there are a lot of integrals, not integrals, derivatives and antiderivatives that you have to do completing the square in order to get some kind of perfect square so you can take the derivative of it or the antiderivative. So how do you use it? Well, the first thing you have is you have a x squared plus 4x minus, let's make this simple. Let's make it a 6. Okay, is equal to 0. And you may not be able, what's 2 times 3? 6. What's 1 times 6? 6. Well, 1 and 6 will give me a 5 or a 7. I would need a 4. 2 and 3 will give me a 1 or a what? A 5. So this is not factorable. So what do? You quit. No. Whenever something's not factorable, you use the quadratic formula because you're trying to find the x-intercepts and you're trying to find the vertex of the function. And we spend the whole Unit 1 and Unit 2 talking about this. So I'm giving you a preview of coming attractions here. Now let me go through the room right here at Anderson. I'm not going to go through because Pendleton, y'all are talking too much and I can't hear y'all. How many here at the Anderson campus has seen completing the square before? 1, 2, anybody? Not much, but you've seen it. Okay. How many of you have seen quadratic formula? Everybody. See? Yeah, gotta depend on that calculator, so you can't make change when you work a register. All right, x squared plus 4x minus 6 is equal to 0. First thing I'm going to do, I'm going to move C. Now, I love it when students, I put move C, and guess what they ask? Where are we going to move it? Well, in quadratic form, you've got ax squared plus bx plus c. So what is c? -6. Where is it? It's on the left-hand side of the equal sign. If I tell you to move c, and it's on the left, where am I telling you to move it?
Right.
There's only one direction you can move it. X squared plus 4x plus blank is equal to 6 plus blank. Add blanks. Now there's two ways. There's several ways to show completing the square. I think there's 4 in all. I picked this one because this is the easiest one for students to grab a hold of. Okay, because it's very methodical and it's very simple. You don't have a lot of theory in it. There's one where you actually leave 6 on the other side and you add a blank and you add a blank and everything's on the left-hand side, and it's kind of confusing to students, so I don't use that method. I take the 6 over to the other side, and then and whatever you do to one side, you have to what? Do to the other, and people latch on to that better than the other methods. So, now here's completing the square. We're going to put this in red because it's very important, so that means you need to highlight it. B divided by 2 squared. B divided by 2 squared. The reason that's in red is because you can't have completing the square unless you have B divided by 2 squared. Now what is B? AX squared plus BX plus C. So B is equal to what? Okay, so 4 divided by 2 is what? 2. And what's 2 squared? So I'm going to put a 4 here, and I'm going to put a 4 here. I have to look at the time because my whiteboard covers it up. We're going to finish this one and then we're going to, I need to go ahead and send this around Anderson campus. Y'all sign, put the date at the top for me. It's Hawthorne, right? Put the date at the top and put your initial beside your name in that column. Okay? Yep, put your initials. Okay, so x squared plus 4x plus 4. Hey, that looks like a what? Shortcut, Hubert. That's right, class. Shortcut number 1 and number 2. This will always give you shortcut number 1 or 2 on the left-hand side. And which one is it?
Number 1.
Number 1, which will give you x plus 2 quantity squared. Is equal to 10. Now, I want you to take your highlighters out, and I want you to highlight that positive 2 and that 10, and take the opposite of both. What's the opposite of positive 2? And what's the opposite of 10? And that's your vertex. And now we're going to continue on and find the x and y intercepts. Now, on a scale of 1 to 10, should you know how to do this? A 2. Okay? If you're sitting at the Pendleton campus or the Anderson campus or the Oconee campus, and you're going, I have never seen this before. That's okay, because we're going to spend Unit 1 and Unit 2 going over it. I do 10 examples of completing a square, going from a difficulty level of 1 to a difficulty level of 10. I do 10 examples. And by those 10 examples, you should be good. All right? This is number -1. I mean, we haven't even started going over it yet. This is a review. Okay? And if you've seen it, great. If you haven't, you're going to. And I'm going to go through it. So, solve for x. Okay, so I got to take the square root of both sides. Now, for right now, I don't want you to use a calculator. X plus 2 is equal to 3.1. It's a miracle. I'm Rain Man. How did I get 3.1? Somebody enlighten me how I got 3.1 just like that. Because the square root of 9 is 3, Hubert. That's right, exactly. The square root of 9 is 3, so what would the square root of 10 be? 3.1. Is it exact? No. But are we worried about exact? We're sketching a graph. In Unit 1 and Unit 2, we're sketching graphs. So it's not that detrimental if you have 3.1015. No, that's because your pencil is not going to be able to get that close anyway if you're graphing it on a piece of graph paper. So 3.1 is good enough for government work. So x is equal to positive or negative 3.1. Somebody's supposed to ask me what the positive and negatives are. Minus 2. X is equal to, what's $3.10 minus $2? $1.10. What is, you owe somebody $3.10 and you owe somebody $2. What do you owe both of them? $5.10. Y'all settle down. $5, and that is your 2 x-intercepts. Now, why do I have a positive and negative right here? The square root can be negative or positive because you're multiplying it by itself. So what's 3.1 times 3.1? 10. What's negative 3.1 times negative 3.1? 10. So you always have a positive or negative when you're dealing with a x-intercept or quadratic formula type situation. You're trying to find both the x-intercepts. Now, let's check it. Let's see if everything lines up. So I kind of draw a sketch right here. And we know it looks like a horseshoe, which is called a parabola, which we're going to go over. And my vertex is -2, -10. -2, -10. And my vertex is 1.0 and -5, 2, 3, 4, 5. So does it line up? Pretty much. And there's your prep. Yeah, no. I'm artistic like that. Now that is completing the square. And that is what we're going to be moving into with Unit 1 and Unit 2. Now, what I want everybody to do for homework in Math 110, this is online as well as this class. I want everybody to get into the homework and get that review homework done and send me what? Send me questions through Ask My Instructor. Please don't do like I got an email this weekend. Here's a question I got on the homework review. And they put the question in the email. They wrote it out, or tried to write it out in the email. Why do you do that? I've went over Ask My Instructor. Evidently, the person didn't listen. Hit Ask My Instructor. It'll send it to me, and you don't have to write anything down. You have to hit two buttons. Ask My Instructor, and what? Send. 2 buttons. That's it. And that's used if you want to challenge a question, if you have no idea what to do on a question, if you think that the question is wrong and you're right and we need to send it to the publisher, if whatever, any concern having to do with a question, you send it to me, Ask My Instructor. And hopefully, come Tuesday, Monday, Wednesday, hopefully I'll have 5 or 6 questions to go over at the beginning of class, or 10, depending on you. This depends on the class. Oconee campus, Pendleton campus, and Anderson campus. If I don't get anything Wednesday, then what am I going to assume? You got it, and we're going on with 1.1 or 2.1 or whatever. So it's up to y'all. Who's got a question on what we went over today? All right, hold on just a minute, and I'll call the roll.